Good morning, my dear students in chemistry. This is General Chemistry 1. Welcome to this virtual class. We're now in week 8, the topic gases. For our learning objectives, at the end of this presentation, the student should be able to describe various observed relationships between the pressure, volume, temperature, and amount of gas, including Boyle's law, Charles' law, Gay-Lussac's law, and Avogadros law. Be able to perform calculations using this relationship. Next, be able to derive a combined gas law and utilize this expression to calculate volume, temperature, and pressure changes in a gas system. Describe the ideal gas equation and perform calculation. Describe Dalton's law of partial pressure and perform calculation. Define and perform calculations using mole fractions, and define diffusion and effusion and how they relate to each other. Properties of gases. So yan lang. 1, 2, 3, 4. We have 6 objectives in today's session. Okay. So let us review or recall lang natin yung mga physical characteristics of gases. Kasi I believe alam na ninyo ito during your lower sciences. Kasi ang senior high school, K-12 curriculum, no? Spiral. So, dahan-dahan itong ini-introduce sa inyo sa lower level. So, ito yung characteristics ng gases. 1, gases assume the volume and shape of their container. Second, gases are compressible. So, madali lang i-compress ang gas, madali din mag-expand yung gas. Third, gases mix homogeneously when confined to same container. When several gases are added to a container, the individual gas particles mix freely due to the arrangement of their molecules, no? Forming a homogeneous mixture in which each type of gas is randomly distributed throughout all the available volume. Fourth, gases have much lower densities than liquid and solids. For example, liquid water is over 1,000 times more dense than water vapor at STP or at standard temperature and pressure. So next, the word barometer comes from Greek words baro, meaning pressure, meter, meaning measure. So barometer is an instrument used to measure pressure. So we have this Evangelista Torricelli, credited with inventing the barometer in 1644. Yung invention consists of mercury-filled container attached to the glass tube into which mercury flowed. So there are ways to measure pressure, millimeters of mercury. The unit is referred to as torr, short ng Torricelli. Standard temperature is 1 atm. This is defined as 760 mmHg or millimeters mercury, which is approximately equal to the average atmospheric pressure at sea level. So the SI unit of pressure is Pascal or PA. So 1 Pascal is equivalent to 1 Newton over square meter. So usually may mga unit din na kilopascals, no, commonly used. And ito yung relationship ng mga units ng pressure. 1 atm, atm is atmosphere, is equivalent to 1.01325 bar. Bar is another unit of pressure, equal to 101.325 kilopascal, equal to 760 mmHg, equal to 760 torr, equal to 29.92 inches mercury, and equal to 14.697 psi, where psi is pounds per square inch. So yung pressure ng ano yan? tire ng sasakyan, that's in terms of PSI. Pounds per square inch. Okay. For example, we have a pressure of a bicycle tire is measured to be 46 PSI at room temperature. So what is the pressure in ATM or in atmosphere? So simply, this is simply a conversion of units. So given 46 PSI and kuha tayo ng part dito sa relationship, 1 ATM is to 14.696 PSI or gawin na natin ito 14.7 PSI. Okay, so yan ang dalhin natin dito sa problem solving. That 1 ATM is 14.7 PSI. Next, i-position niyo yung 14.7 na sa baba. Sa taas ang ATM kasi yan ang direction ng ating conversion. So next is to multiply 46 times 1 divided by 14.7. Cancel PSI. The answer is 3.1 ATM. So therefore, 46 PSI is equivalent to 3.1 ATM. Okay. So next is atmospheric pressure. This is also known as barometric pressure. So after the barometer, so this is the pressure within the atmosphere of the Earth. The standard atmospheric pressure symbol is ATM, is a unit of pressure. So ATM is a unit of pressure. Defined to be, so yung kanina na mga conversions. So if we go up in altitude, there is less air in between the ground and the atmosphere. The smaller amount of force means that atmospheric pressure is lower at higher altitude. Now, since this is common cruising altitude for commercial airplanes, yung pressurized cabins are needed for the comfort and survival of the passengers. So kung walang mga pressurized cabins sa airplane, may mga discomfort yung passengers. This is because the density of air decreases along with decreasing air pressure. So there is less oxygen in a breath of air. And you probably notice this effect in high mountain areas as it often feels harder to breathe. That's because of pressure. Okay. So we have the relationship between pressure versus volume, pressure and volume. Robert Boyle was particularly interested in the relationship between volume and pressure. He invented one of the earliest air pumps, which allowed him to create low pressure environments. So in his experiment, nakita niya that volume is inversely proportional to pressure. So mathematically, P times V is equal to constant, or P is inversely proportional to V. Okay, so we have P times V is constant. This constant depends on temperature and amount of gas in a given sample. So this result observation published in 1662. This is now known as Boyle's law. So let us have this subscript. Kung may makita kayong subscript na 1, meaning initial condition, P2, meaning, or yung 2 sa P2, indicates final condition ng pressure. Okay, so we have this formula, Boyle's law. So the product pressure and volume sa initial condition is equal to product pressure volume ng second condition. Let's have this example. So a sample of oxygen gas has a volume of 150 ml when its pressure is 0.647 atm. What will the volume of the gas be at a pressure of 0.987 atm if the temperature remains constant. So ano-ano yung mga given dito? ml, this is volume. This is V1. And this is P1. Observe na nasa isang sentence lang, meaning isang condition lang ito. So what will be the volume? That's V2, our unknown, question mark, of the gas sa pressure na 0.98 cm atm, 87 atm, our pressure 2. Now, temperature remains constant. Okay, so recall lang natin itong Boyle's Law formula. This is the mathematical formula ng Boyle's Law. Okay? So since given lahat, pahanap si B2, then iwan natin si B2 sa one side ng equation, i-divide natin dito sa left side. Or divide the left and right side of the equation by P2. Okay, so this is not the simplified form. All you have to do is to plug in the values and use your calculator. Kung makuha niyo yung 98.3 ml. Okay, so I hope you can follow. Next, temperature. So a thermometer was developed a short time after the barometer. So though crude thermometers had been available for quite some time, Daniel Fahrenheit constructed a more accurate thermometer in 1724 using mercury in glass. So because the height of the mercury in the thermometer was relative measure, certain fixed points needed to be defined. Originally, Fahrenheit defined 1:1:1 mixture of ice, salt, and ammonium chloride as 0 degree Fahrenheit. And the freezing or melting point of ice is as 32. So on this scale, we have 96 as body temperature. Boiling point is 212 Fahrenheit. And in 1736, we have under Celsius devised a slightly different scale, which also had two fixed values, freezing and boiling. So we have 0 as freezing, 100 as boiling points. So this is freezing and boiling. So shortly after his death, the scale was reversed, resulting in the form that is used today. The Celsius scale is a standard way to measure temperature in most parts of the world. Okay, so next we have the absolute zero. The idea of absolute zero and absolute temperature were conceived in 1848 by Lord Kelvin. So, had observed that for every 1 degree drop in temperature, a sample of gas contracted by a uniform amount, specifically 1/273 of its volume at 0. So, he interpreted this to mean that -273 degrees Celsius is the lowest achievable temperature. Okay, so what is absolute zero? This is the lowest possible temperature where nothing could be colder and no heat energy remains in a substance. Or it is a point at which the fundamental particles of nature have minimal vibrational motion, retaining only quantum mechanical zero-point energy-induced particle motion. Okay. So itong absolute zero, parang yung mga molecules hindi na mag-move, no? But then may mga study pa rin na nagsasabi na it is very impossible to attain this absolute zero. Okay, next is the relationship between volume and temperature. So Charles' law. So Charles and Gay-Lussac, nagka-partner ito sila, proposing that for a fixed amount of gas at a constant pressure, the volume is directly proportional to its absolute temperature. So take note, absolute temperature. So V is directly proportional to T. So when we use a constant, then V over T is K, where K is constant that depends on the pressure and amount of gas. Now for two conditions, we are given V1 over T1 equal to V2 over T2. Okay. Now, anong application dito? So, in winter, due to lower temperatures, the air inside a tire gets cooler. So, mag-shrink ang tire. While in hot days, the air expands with temperature. So, mag-expand yung tire. Okay, so we have this example. A sample of neon gas occupies a volume of 752 ml and temperature of 25 degrees Celsius. So, sulat agad V1, T1. So, what volume will the gas occupy at 50? So, this is our T2. At saka pinahanap yung V2. So, pressure remains constant. Okay, so first is that kung ang unit ng temperature hindi naka-express sa absolute value, sa absolute temperature, Kelvin, we need to convert that. So, in converting Celsius to Kelvin, let us simply add 273 to Celsius. No? So, 25 plus 273, our T1 is 298. T2 is 50. Plus 273 is 323. So, V1 is 252, V2 is unknown. Then recall the formula of Charles' law. And since we want V2, if we want V2, move natin itong T2 doon sa tabi ng V1. So, this is now the simplified formula. So, V2 therefore is, substitute all values. V1 is 752. This is it. T1 is 298. Ito. And T2 is 323. Ito. And then use your calculator. 752 times 323 divide 298. The answer should be 815. Okay, next is Gay-Lussac's law. This describes the relationship between pressure and absolute temperature. So it says that at constant volume, the pressure of a gas is directly proportional to its absolute temperature. So this relationship is also sometimes attributed to Monton's. Sabi ng Gay-Lussac's law that pressure of a gas is directly proportional to absolute temperature. So when we introduce a constant, therefore we have P over T over constant. Okay. For two conditions, we have P1 over T1 is equal to P2 over T2. So, an example, we have a gas in an aerosol can exerts a pressure of 3 atm at 25 degrees Celsius. So, label agad niyo ito. Ano ito? This is T1. This is T1. Directions in the can warn user not to keep the can in a place where the temperature exceeds 52 or T2. What would the gas pressure in the can be at 52 degrees Celsius? So, anong pinahanap? The pressure. Sabi kanina that pressure is directly proportional to T. So meaning, pag mataas ang temperature, tataas din yung pressure. Now, kung hindi na kaya ng can yung pressure, eventually, or pag higher pa na temperature, alam niyo what will happen to the can. Na hindi na kaya yung pressure inside due to the higher T. Then, pwede yan putok, no? Or due to expansion, hindi na kayanan ng can, no? So, first is simply convert Celsius to Kelvin. And then we have P1. And then recall the formula. And then since P2 ang unknown, so multiply na natin ito doon. Si T2, tabi ng P1. Yes, sa lahat ng mga temperatures, pag ang problems involving gases, lahat ng temperatures, for example, Fahrenheit, Celsius, tapos gases yung problem, dapat i-convert muna ninyo to Kelvin. Before, kasi magkaiba ang value ng right answer. Okay, so na-multiply na natin ito. Ito yung simplified form ng formula of P2. The next thing is to plug in the given values. P1, T1, T2. Then use your calculator. So observe na makancel ito, giving us ATM. Again, ATM is atmosphere, a unit of pressure. Okay, next is combined gas law. This combine the relationship between this the laws of Boyle's, Charles, and Gay-Lussac's. So created a relationship between P, V, and T. So ito ang formula ng combined gas law where P1, V1, T1 is the pressure, volume, temperature in initial condition, P2, V2, T2 for final condition. Okay, let us analyze the problem. A helium-filled balloon has a volume of 50 liters, T1, at 25 Celsius, T1, and 1.08 atm, that's P1. What volume, so unknown V2, will it have at P2, 0.855 atmosphere, and P2, 10 Celsius, degrees Celsius. Okay, so again, kasi naka-Celsius ang temperature, i-convert natin yan to Kelvin. So 25 and 273 is 298, 10 and 273 is 283. Next, V1 is 50. P1 is 1.08. V2 is unknown, and P2 is 0.855. Okay. Next, using the combined gas law formula and finding V2. So, iwan natin si V2 dito. So, one side ng equation, move natin ito sa taas, P2 sa baba. So, ito yung simplified form ng formula. The next thing is to plug in the given quantities. So, again, use your calculator to obtain the final volume. Cancel ATM with ATM. And Kelvin, K with K, cancel. So, giving us L, our unit. So, I hope na na-follow ninyo ang concept. Let's move. Continue tayo. Avogadros Law. So in 1811, shortly after the work of Charles and Gay-Lussac, Amadeo Avogadro was also studying the relationship between pressure, volume, and temperature. He postulated that if you compare two samples of an ideal gas at same temperature, pressure, and volume, they contain the same number of molecules. So this became known as Avogadros Law. This means that at a given pressure and temperature, the volume of a gas is directly proportional to the number of molecules present. So V is directly proportional to the number of molecules present. So introducing constants, so V over N is equal to K. Then V is the volume, N is amount of gas in moles, and K is proportionality constant. So if we add the Avogadros law into the combined gas law, we could create this ratio, P times V over T over N as constant. Okay, so this is now the ideal gas law equation. So PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is constant, equal to 0.0821 liter atmosphere over Kelvin mole. And T is temperature. Observe na yung unit ng volume must be liters. Ang unit ng pressure must be atm. Unit ng N must be mole. And unit ng T, Kelvin. So, dapat ito yung masunod na mga units. Kasi, let us follow the units ng constant R. So, kung hindi naka-express in ATM, convert ninyo to ATM. Kung naka-ml yung volume, then convert that to liters. So, another example, we have sulfur hexafluoride is a colorless, odorless, and very unreactive gas. Calculate the pressure in atmosphere exerted by 1.82 moles is our N at 69.5 degrees Celsius is our T. When confined to a rigid steel vessel with a volume of 5.43 liters. So this is V. Given V, N, and T, and we are going to solve for pressure. P is unknown. Okay? So since we are given 69.5 degrees Celsius of temperature, then let's add 273 para ma-convert yan to Kelvin. And next, recall the formula, ideal gas formula. Since we want P, kung i-recall natin, PV is equal to N RT. Kasi we want P, so P therefore is equal to N RT. I-divide natin yun ng V. So this is V slash V. Okay, so next thing is to substitute. Yung N is 1.82. Ito na yun. R is constant. And temperature. Ito yung volume. So use your calculator. 1.82 times 0.0821 times 342.5 and then divide 5.43. So the answer is 9.42 unit ATM. Okay, so next is Dalton's law of partial pressure. In our hypothetical gas mixture, we could measure the total pressure exerted by the mixture using barometer or other instruments. However, we cannot directly measure the pressure exerted by each individual components. The concept of partial pressures was first described in 1801 by John Dalton. So the law states that if two or more gases are mixed in a container, each one will exert the same amount of pressure as it would if it were by itself in a container of the same size. As a result, the total pressure of the mixture will be the sum of the partial pressures. Okay, this is how to find for the total pressure ng mixed gases. So total pressure is equal to partial pressure of oxygen plus partial pressure of nitrogen plus partial pressure of argon if these three gases were combined. Okay, so to solve for the mole fraction, where mole fraction expresses what fraction or percentage the moles of a particular substance contribute to the total number of moles present. So, parang percentage ng gas in a total mixture of gases. Okay, so may problem tayo to illustrate partial pressures. If you had a gas mixture that contained 3 moles of argon and 6 moles of oxygen gas, what is the mole fraction of the argon? That is, if the total pressure is 760 mmHg, what is the partial pressure of argon? Okay. Ipahanap ang mole fraction ng argon. That's XFA or XAR. XAR. And then partial pressure or P of AR. Yan ang ating unknown. Okay. First is to calculate the mole fraction of argon. So where the total is 3 plus 6. So to find X of AR is moles of AR divided by total moles. So AR is 3, total is 9. And if ipakuha yung mole fraction ng O2, simply 6/9. Now, since mole fraction ng argon lang, so ito lang ang kinakailangan ng problem. And what about the partial pressure? So to solve for partial pressure, this is mole fraction of argon multiplied by total pressure. So ang mole fraction argon is 0.33 or 33% of 760 mmHg is 253 mmHg. So kung ipakuha din yung P of O2, then kung ano ang makuha na value dito, 6/9. 6 divided by 9 is 0.67. So 0.67. So 0.67 of 760. Yun ang P sa O2. By the way, if you want to check, dapat yung total ng mole of AR, i-add niyo sa mole ng O2 or mole fraction ng O2, the total must be 1. Similarly, when we add P of AR to P of O2, the total must be 760 mmHg. That's the way of checking. Okay, so next, a gaseous mixture consists of 380 grams of fluorine gas and 100 grams of neon. If the volume of the container is 112 liters and the temperature is 273 Kelvin, calculate the following. A, moles of each gas, total moles of all gases, mole fraction of each gas, total pressure of mixture, and partial pressure of each gas. Okay. So let us solve letter A, moles of each gas. So the moles of each gas, yung gases nandoon is IF2 at saka Ne. So ang mass ng F2 is 380 grams. So divide natin yan sa molecular mass ng F2. And then 100 divided by ng molecular ay atomic mass ng neon. So that's why we have 5 mole F2 and 2 moles Ne. Next is to find the total moles of all gases. Basta dalawang gases lang ito, chlorine at saka neon, then i-add lang natin ito. That we have 15. Next, to find the mole fraction of each gas is that a mole ng F2, which is 10, divided by total na 15. Sa Na naman, 5 moles, divide 15. So the result is 0.33. F2 is 0.67. Again, a way of checking dapat the total is 1. So the total pressure of a mixture using the Avogadros law. So from PV is equal to nRT to find P is equal to nRT over V. So plug in lahat yung mga given. So the partial total pressure ng dalawang gases is 3 atm. For partial pressure of each gas, so alam natin na yung mole fraction ng XF2 is 0.67 and XNE is 0.33. We have to multiply that by the total pressure ng mixture of gases. So finding the partial pressure of each gas. Finding the partial pressure of each gas. So alam natin na yung partial pressure ng mole fraction ng F2 is 0.67 and mole fraction of neon is 0.33. So yan ang gagawin natin dito pang multiply sa total pressure ng dalawang gases. So multiply natin ito. So that's why we have 2 atm. It's 2.01. And then 0.33 times 3 is 0.99. So when we add the 2, a way of checking kung tama tayo, i-add natin itong dalawa. The total must be 3. Okay, so yan how to use the partial. Okay, next, diffusion and diffusion. What if a gas is transferred to a larger container? Eventually, the random motion of the gases or gas particles will result in an even distribution throughout all the available space. So this process is referred to as diffusion. And diffusion is the process of a confined gas escaping through a tiny hole in its container. Can be observed by the fact that a helium-filled balloon will stop floating and sink to the floor after a day or so. So this is because the helium gas diffuses through tiny pores of that balloon. Both diffusion and diffusion are related to the speed at which various gas molecules move. So diffusion describes the process of a gas spreading out at a constant pressure, such as throughout a room. While diffusion describes the process of a gas spreading out from a high pressure surroundings to lower pressure surroundings. Okay, so Scottish chemist Thomas Graham studied the rate of effusion and diffusion for various gases. Graham's law of effusion states that the rate of effusion or diffusion of a gas is inversely proportional to the square root of the molar mass of gas. So mathematically, this is the Graham's law of effusion. So rate of effusion of gas A divided by rate of effusion of gas B is equal to square root of molar mass of B or gas B over square root of molar mass of gas A. Okay, for our lesson summary, gases assume the shape of their container and are highly compressible. Gas particles demonstrate elastic collision between themselves and with the container's wall. Pressure is equal to force over area. Atmospheric pressure can be measured with barometer. Atmospheric pressure at sea level is 14.7 psi or pounds per square inch, or this is equal to 1 atm at 25 degrees Celsius. Atmospheric pressure decreases as the altitude increases. Pressure and volume are inversely proportional at constant temperature. Volume and temperature are directly proportional at constant pressure. Pressure and temperature are directly proportional at constant volume. Pressure, volume, temperature are related by combined gas law. The volume occupied by a gas at a given temperature and pressure is proportional to the number of gas molecules present. For ideal gas, we have PV is equal to nRT, where R is constant equal to 0.8206 L dot atm over K over mole. And Dalton's law of partial pressure states that the total pressure of a gas mixture is the sum of the partial pressures of each gas component. Mole fractions describe the fraction or percentage of a mixture that is made up of a particular substance. And the rate of diffusion and diffusion for a gas are inversely proportional to the square root of its molar mass.